systems of equations. We're going to start chapter 3. Chapter 3 is all about systems. Today we're going to begin by solving systems of equations by graphing. There are other ways to solve. We looked in Algebra 1 and Algebra B at ways like substitution and elimination, and of course graphing. We're going to start today with graphing. These are just basic equations. They're all in slope-intercept form. We're going to graph them like a linear equation. So look at the first equation with me, please. When I'm solving a system of equation, I'm trying to figure out the ordered pair that works for both equations. If these two lines intersect, they should have one solution. So we're going to solve these by graphing. We're going to graph each line to figure out what point makes both of these equations true. So to graph the first equation, we have a y-intercept at -1. So we'll start by putting a dot at -1. Our slope is -2/3. So from this dot, we're going to go down 2, 1, 2, and right 3, and put a dot. We could also go up 2 and left 3, and put a dot. I need at least 3 points. You can put more on there if you want, but at least 3. Take your ruler and draw the line through the points. The second equation is x equals 3. This is kind of a special graph. What does that graph look like? Vertical. Good. It's going to be a vertical line at 3. So on my x-axis, I'll find 3, and I'll draw in my vertical line. My solution is where these two graphs intersect, where they meet. Where do these two graphs intersect? 3, -3, that point right there. That is my solution. I do need to state that ordered pair, 3, -3. That ordered pair where the lines intersect. Now, when I have a solution, when it's actually a solution, it means that I could put those ordered pair, that ordered pair into my equation, and it's going to work for both of the equations. In fact, it's the only ordered pair that should work for both equations. So I'm going to put 3 in for x, I'm going to put -3 in for y. Remember, if it works, if it really is a solution, it makes the equation true. So put -3 in for y. -2/3 times 3 minus 1. So I substituted the ordered pair in. Now I'm going to calculate -2/3 times 3 is -2. And -2 minus 1 is -3. It worked. It checked out. So I know that it worked for the first equation. Try it in the second equation. In the second equation, the only thing we can put in is 3 for x. So I put 3 in for x. Of course, that's going to be true. It worked out. It should work like that every single time. Look at example 2. Solve this system by graphing. The first equation has a y-intercept of 4, so I'll put a dot at 4. The slope is 7/4. That means I'm going to go up 7 and over 4. I probably don't want to go up 7 and over 4, do I? I can avoid it. I'm going to start by going down 7. 1, 2, 3, 4, 5, 6, 7. And left 4. 1, 2, 3, 4. Now I need a minimum of 3 points, so I'm going to have to rise 7 and run 4 to get my third point. So let's just estimate 1, 2, 3, 4, 5, 6, 7. And run 4. 2, 3, 4. Once we have our 3 points, I do want you to use the straight edge. I do not want you to freehand these. Please use the straight edge so your graph is a little more exact. For the second equation, we have a y-intercept of -1, so I'll put a dot at -1. The slope is 1/2. That means rise, run 1, run 2. Rise 1, run 2. Now, instead of just sketching in my line right now, I'm going to go ahead and see if I can't continue to make points with my slope. So I'm going to go down 1 and left 2. I'm trying to find where my lines intersect, and I want to know that exact point. I don't want an estimate, I want to know the exact point. So I went down 1 and left 2 until I got to a point on my line. Once I was at that point, I could easily sketch in the graph. So where do these two lines intersect? -4, -3. And we said if our ordered pair is a solution, then it works. It works for our equation. So I'm going to once again substitute into these equations to see if it's going to work. So -3 equals 7/4 times 4 plus 4. 7/4 times 4 is 7. That's -7 plus 4, and -7 plus 4 is -3. So it worked out in the first equation. In the second equation, put -4, -3 in. Here on the right side, so we have -3 equals 1/2 times -4 minus 1. Half of -4 is -2, and -2 minus 1 is -3. That worked out as well. You don't have to check them every time, but it's a good idea to check them to make sure that you've got the correct solution.
So really don't have to do that.
I'm not going to require that to see on your homework, but I would totally to make sure you got the right answer.
I'd say a good rule of thumb would be like, if you're not sure if it's right or wrong.
Exactly. If you're not sure, check it. That way you know either you did it right or you did it wrong. That's a good point, James. Number 3, the first equation has a y-intercept of -3, so put a dot at -3. The slope is what? What is that number in front of x? -1. So go down 1 and right 1, down 1 and right 1. I like to make my graph have lots of detail. I want to make sure I know exactly where these lines are going to intersect. So I'm going to put lots of points, especially on this one when you have a small slope like -1. The second equation has a y-intercept of +3, without a +3, and a slope of 5. So I could go up 5 and right 1, or you could go down 5 and left 1. If you go down 5 and left 1, that should be a point right on your graph. I went ahead and did my third point up here. I went up 5 and right 1. Just a reminder, I do want you to have at least 3 points. You can have as many as you want, but at least 3. I've got my 2 lines drawn in. Where do these lines intersect one another? -1, -2. Please be sure to state that point. Okay, for the first equation, the y-intercept is at 1, and it has a slope of 2. That means we're going to rise 2 and run 1. Rise 2 and run 1. For the first graph, I like to put lots of points. That way I'm certain to get something. So those are one of them. For the second equation, I have a y-intercept of 4. And I have a slope of -1. So down 1 and right 1, down 1 and right 1. These 2 lines intersect right here at 1. If you haven't already done so, I'd like for you to go ahead and try the last one. The first equation has a y-intercept of +2. Let's put a dot at +2 on our y-axis. Slope of -3/4, so we'll go down 3 and right 4. Could have also went up 3 and left 4. The second equation has a y-intercept of -2 and a slope of 1/4. Rise 1 and run 4, or go down 1 and run 4. Looks like these two lines intersect at 4, -1. Okay, so today we're solving systems of equations by graphing. Plotting our y-intercept and rising and running with our slope. Remember, your answer is your ordered pair, but I do need you to graph it so that we know the solution.